No. How do you know that they are waiting in there? That's what I am asking. You have any indication? You are only telling that they may be waiting, right? Okay. Then no. Say you can start so that you can start that observatory. Yeah. And then another 1 minute you can, another 2 minutes you can start the recording also. See, even today we have problem in booking ticket to Bangalore.
Okay, sir.
No, because we are so much used to SBC and things like that.
Okay.
இப்போ வந்து வேற ஏதோ ஒரு நேம் கொடுத்திருக்காங்க. Every time I have to go to Google, make a search and then
you have to write. Sir, and for your information, probably this month or next month they may give an announcement that Shivnadar University Chennai is going to come up, sir.
Oh, very good.
They are going to start functioning from next year onwards, but they may give
it was approved along with the Sai. It was approved.
They are going to start BCom, BA in data science, and BTech CSE specialized in IoT.
Okay.
Only 3 courses.
Very good. Okay. But SSN will remain SSN, right?
Right now it will remain as SSN, sir. Hope so that in near future they may merge both the entities. That is the idea, sir.
Good. Yeah, that was anticipated, but in meanwhile they got the approval for a state university.
Yes, sir.
We are wondering what is going to do. Yeah. People are another few minutes we will start. 6:05. Hello. Can we start?
Yes, sir. Good evening, participants. ACM Chennai, IEEE CS Madras, and CSE Chennai cordially invite you to a webinar on Demystifying IoT Protocols by Dr. N. Bhalaji, Associate Professor, Department of IT, SSN College of Engineering, Chennai. About the presentation. IoT, Internet of Things, is relied upon to introduce a period of firmly associated world through cutting-edge availability of gadgets, frameworks, and administrations. IoT goes past M2M, machine-to-machine communication, and spreads a variety of protocols, verticals, and applications. It is estimated that in excess of 50 billion gadgets will be associated with the Internet of Things by 2020. The Internet of Things guarantees a mechanical transformation, yet associated with the Internet of Things. In order to function admirably, all the gadgets need to communicate in a similar language. However, right now the ecosystem is divided into various layers of the protocols. This talk orients towards the different protocols that are at present dominating the IoT. About the speaker, Dr. N. Bhalaji is serving in academia for more than 16 years. He received his BE and ME degree both in computer science and engineering, and PhD specializing in trust-based routing approach for managed from Anna University, Chennai. His current research interests include application of trust over information and communication domains, namely Internet of Things and blockchain technologies. He is also an enthusiastic learner of machine learning algorithms and its applications in computer networks. He is a recognized supervisor of Anna University. 2 scholars have completed their Viva hours, 4 submitted their thesis, and 4 are pursuing. He is serving as a doctoral committee member of Anna University, VIT, SRM, and Satyabama University, and as a member of the Board of Studies in SRM, Valliammal Engineering College, and Wales University, Chennai. He is a recognized proctor of TIA, Global Certification Agency examinations, is actively involved in industrial consultancy projects, namely HCL TechB, Blue Lotus Technologies, and Reddington CSR. He is a member of professional societies such as ACM, IEEE, IACS80, and IAENG. He is acting as a faculty coordinator for online internship of SSN students at Carnegie Mellon University, USA. He has published around 50 articles in indexed publications such as Scopus. To his credit, he has over 10 online certifications in the verticals of Internet of Things, blockchain, and machine learning. Over to Mr. N. Bhalaji.
Thank you, sir. Thank you for the intro. Good evening to one and all who have joined in this pleasant evening. So the one thing I would like to introduce myself is I'm an enthusiastic and active learner, and that's what keeps me pushing both in career and personal life. So with this introduction, I would like to get into the topic. Today, I'm going to discuss about demystifying Internet of Things protocols. So the lecture is arranged in this way. I'll be giving a basic introduction about IoT, what, why, what, and how, and preliminary information and basic exposure to Internet of Things, IoT protocols overview, RPL. Some of you may be aware that IoT protocol stack has a lot of protocols in each and every layer depicted. So I'll be focusing today on RPL, bit detail, and I'll be touching upon what are the different IoT hardware and software available across the globe, and what is the opportunities which are available in the IoT landscape, and what are the IoT startups which have emerged in the recent past with respect to our country. The world is changing. I hope you all will accept with me. The world is constantly changing. So we have seen how these technologies have changed the way in which we see automobile industry. We have seen what changes it has brought into the hardware, software, mobile, energy, computing, space, and so on. So we have to accept the fact that this world is changing. So once we accept this fact, we are in for a bigger change which is going to happen in the next decade. Coming to the point, are we using IoT? Could a participant say me, are you using IoT? Yes or no, just give me one justification. If the answer is yes, then how are we using IoT? If the answer is no, how are we not using IoT? We will try to see with a simple example. I hope all of you today can live without even air, but we cannot live without smartphones. That's the reality that has become an integral part of our life. So if you look at smartphone, let's look very closely. A smartphone worth of 5,000 rupees know what are you speaking to. It knows your face. It knows your emotion. It knows your voice. It knows where are you. It knows whether your how many lights are switched on in your room. It also knows where at what distance are you keeping the phone and speaking to it. So these many informations are available in a small or a ordinary smartphone worth of 5,000 rupees. And I would like to again reinstate that the whoever have started using smartphone, you are already into the world of IoT. You are already into the world of IoT. How? A normal smartphone in an average has at least 5 to 6 sensors inbuilt. So what happens here? These sensors recognize the parameters or the entities, whatever I listed now, and it could also be communicated. A very common example, your mobile phone knows how many steps you have walked on a particular day. For say, in case if you are using an iPhone, there is an app called Step Counter. or even say Windows or Android mobile phones, you have a lot of apps which could easily measure how many steps you have walked on a day. It could also give you a total picture on a weekly basis, fortnight basis, and monthly basis. That could also be communicated to your medical guide or a doctor. He can monitor from his place whether are you walking properly or sufficiently as per his instruction or not. Just to throw an example. So now I'm trying to give the justification that we are all part of IoT and we have already become a users of IoT. What next? See, always there has been each and every decade, we have seen a monumental change, paradigm shift change in the technological era. If you look at 1980s, this was known as the era of computer and process optimization. Can you say me who ruled this era, 80s era? Participants, can you unmute and could you say me some answers?
Companies like IBM, Mac.
Yes.
PC, PC XP, PC 80s.
Okay. Okay.
Then Pentiums came, and we were the first ones to launch in India the people's computers from Government of India Enterprise.
And I think, if I'm right, in late 1970s itself, HCL
I'm
also
mid 80s.
Mid 80s. Okay. In late 1970s itself, HCL also, not in name of HCL, after launching calculator, they also launched.
Absolutely. Yeah. They had a tie-up with the UP government.
Yes. In parallel with IBM, they also launched their desktop.
Yeah. But when Mr. Rajiv Gandhi was the Prime Minister, we launched the people's computer.
Sam Brittato, when he became an advisor for Indian government as an IT advisor, I think that's the
right.
point.
Sam Brittato was the technology mission advisor, and Mr. P.S. Deoda was the Electronics Commission chairman,
Yes.
and Sam Brittato was the Telecom Commission chairman.
And that's the point where we actually, India got our doors got open to all these technologies and software.
That was a revolution. And we were the first ones to launch throughout India the people's computer, less than 10,000 rupees. It's a PC, simple PC. Great. Then we moved on to PC XTs, then 80s, then Pentiums, likewise.
Great. It's very nice to speak with you, sir, because we all cite some examples from West.
Thanks a lot.
I'm just moved because I'm getting an example from our country. Thank you so much.
Thanks a lot. Thank you very much. Bye-bye.
Bye-bye. So the intention here is, 80s were the period where the computers were actually coming into the they were coming into our human life, and as now we discussed, IBM was the one who were dominating globally. 90s, if you look at 90s, someone said that Mac and Microsoft. 90s was the era of operating system. I need not to say Microsoft, Windows. That was the period where operating systems were the one. See, Microsofts were becoming a huge giant. They were completely reshaping. They were completely revolutioning the technological era. So they were the one who were ruling in the 1990s. If you look at 2000, the early 2000, information and web retrieval. Whenever we hear the word web, what comes to our mind? Google. So Google came up with the search engine, they came up with the email IDs. So that was the era where the web was actually getting democratized and it was reaching out to the common people. So that was the era of 2000. And it followed with a lot of slew of apps, slew of softwares like RCode and other thing. And if you look at 2010 and so on, that was the era of, I would say, the highest innovation, like Amazon, Uber, Ola. The beauty is, these guys, they didn't possess any wardrobes. They didn't possess any physical stores. Uber didn't have even a single taxi in its name. But by merely using the services which were available in the technological arena, they were able to build a mammoth of a castle like Amazon or Uber or Ola. So this was a prime example how you can leverage the technology to its best. And in 2020s, we are again poised for a new change. That is what we are debating in name of Industry 4.0, and even if I'm right, we have already inched into Industry 5.0. I need not to say, when I say Industry 4.0 or Industry 5.0, it is all about amalgamation of different technologies like machine learning, artificial intelligence, Internet of Things, blockchain technology, augmented reality, and so on. And traditionally, if you see, initially the technologies were getting differentiated. If you look at the history, that's what happened. They were all getting differentiated at one phase of time, but now this is the era where everything is getting integrated. I cannot imagine IoT without machine learning algorithms. I cannot imagine blockchain without data. I cannot imagine drone technology without processing or image processing algorithm. So they are all interlinked, and they enhance each other's application, and that's how they are all getting into an integrated entity, and it's poised to change the world again. Internet of people, if you look at the Internet of people, see, when you look at the internet, personally I feel internet is the transformative technology or transformative discovery which has happened in the last decade. I value all other innovations, all other inventions, but personally, as a technology person, technological savvy, I feel internet has completely changed the way in which we look at the life. And even for your information, internet has been quoted as birthright by UN. So it is considered as a birthright by UN. So internet has changed the way in which we look at the world. The speciality of internet is, if you look at internet, whatever is being propagated in internet, either an image or a video or an audio, it's all by the people and for the people. I hope you all will agree with me. It was by the people and for the people. So it was interconnection of people. They used to communicate among themselves in the form of sharing documents, sharing photos, sharing their thoughts, and so on. So that was the era. So internet, we already know, it changed the way in which we looked at the entire globe. And again, we are today going to talk about Internet of Things, which has already arrived. I should not say that it is going to be a future technology. It has already arrived. It is here, very much here. So Internet of Things is a technology where the things communicate or start interacting among themselves. It may be fuzzy, but I'll try to explain you, decode, and say how things could start interacting among themselves. What it is, why should you care? So, okay, let it be a technology, let it be a new paradigm, but how it is going to impact me as a common man? Let's find out the answer. Before that, why we need such kind of technologies? We want to receive more data. We know, Jeff Bezos recently quoted that data is the next fuel, right? So the country which has more data will be the one which will be the richest in the near future. So data is the next fuel. So we need data. We need data for everything. We want to automate. This has been again a very contradictory topic. Like a human always wants to automate, but again he is also has a fear of losing the jobs. But this has been the case from industrial revolution. So we always love to automate things. We want to make things faster. Who will contradict with me? See, we want everything to happen fast. We want to control the stuff. We always love to control, see, that's what happens in our personal and professional life. We always try to control the other people. What is IoT? I think from the picture you can understand IoT has a lot of definitions which are available in the web, and it is also individual centric. But my definition or my explanation of IoT will be my version. You don't have any universal code, or there is no Bible from where I can say that IoT only states this. It is subjective, it's individual centric, and it's context dependent. So this example, I think probably you all know the famous story of blind man touching the elephant and visualizing them or explaining them how an elephant will look like. This guy will say that elephant is more like a thin rope which has hairs at the tail part of it, and this guy will say it is more of a elliptical shape, and this guy will say it is more of a cylindrical shape, and so on. Kevin Aston is considered to be father of Internet of Things. He was the guy who coined this word Internet of Things. He used this for the first ever time in 1999, and that's the point from where we started using this word Internet of Things. There are other equivalent words. Say we can also call them as Web of Things, machine to machine interaction, device to device interaction, and Internet of Objects, and so on. So there are a lot of definitions, a lot of names. These are all Wikipedia definitions. I'm not going into it. Anyhow, I'll be sharing the slides with the organizers. You can go through that. Different definitions. Coming to the crux, capabilities. If you look at the human capabilities, we have the capability to hear, taste, smell, touch, and sight. So these are all our innate sense, which is which comes along with our birth. We don't try anything to develop this. It comes innately as a human being. Imagine what happens if we are able to import these capabilities into machines or things. What happens if my thing starts to hear? What happens if my things start to taste? What will be the consequence if it starts smelling, touching, and sighting? So this is what IoT is all about. So we are trying to transfer these capabilities of human being, the innate human being capabilities, into a machine or an object. So that is the effort. Already hearing, your mobile phone can hear. Tasting also, see, there are some devices which have come up in the West. I recently saw that in a video where they give you a laptop or a tab, and once you order your food, that will be visible there. You can lick and taste it. Okay, it's more like virtual reality, but they have also embedded taste into it. I have to again completely decode and find out how they have done it. But I saw that video. I can also share it with you. Smelling, I need not to say. A lot of devices are there which could play a vital role in making a device to smell. Touch, we all know, vibrations. Sighting, CCTV cameras, your mobile phones, and so on. So this is what I was talking about. What will happen if we are able to import this sense and communication capability? Not only sensing, but after sensing, what happens if they communicate among themselves? Very simple example. Imagine a smart refrigerator in your house. It knows what are the items available inside it. It can show you based on the items available inside that, it can give you a suggestion for what kind of menus you can make. For say, if it has a milk and if it has a bread, for say, it can say that you can have a milk and bread for your dinner. Or if it has a tomato, if it has a coconut, it can say, it can also suggest you that you can prepare a tomato chutney and so on. And to the extent, in case if some items are very low in number, it can also give you an alert. Even let's imagine that you are in office and you are on the way back to your house. Your refrigerator can communicate and inform you that, hey, the number of tomatoes or the quantity of potatoes quantity of vegetable in the refrigerator seems to be low. It's a high time for you to go and purchase a vegetable. This is obvious. So these are all some examples. What will happen if the things start sensing and if they start communicating among themselves? And for your information, like Facebook, there is another concept called Thinkbook. It is also actually popping up. And just imagine how good it will be in case if our vehicles communicate among themselves during a traffic. For example, I'm on the way to OMR. If the the other vehicle which is already there in the OMR, it senses that it is there is a heavy traffic in that place, and it can communicate to the vehicles which are yet to reach there. So it will be easier for me to understand that some issue has happened there, and it's a high time for me to change my direction. So these are all some examples, day-to-day examples, which we could get benefit out of leveraging this IoT. IoT in reality, you all know, the smartphones, they have a gyroscope sensor, accelerometer sensor, and they can also work, or they can also function as a life-saving mechanism. They can also act as a life-saving device where they can measure your heartbeat. If they find any abnormality, they can also communicate to the respective authority. So that extent smartphone can act. This is a jawbone. This jawbone, it's more like a bracelet. This bracelet can record how many hours I have slept on a previous night, and what is my average sleep pattern for a particular week or a particular month, and so on. You would have heard about people suffering from lack of sleep, insomnia. There are a lot of diseases which could pop up because of missing your quality sleep. So this bracelet can do that. Not only that, it can record your temperature. It can continuously send the temperature to the caretaker, and so on. This is a thermistor. Thermistor is very commonly used in the Western place, where it can sense what is the temperature level available inside your home. Based on the thermistor reading, you can automatically adjust your AC temperature inside the house. Otherwise, you can also decide whether to open the windows or not. So thermistor, you can also note down this name, Nest. We will also come across this in our future slides. So thermistor plays a very vital role. Even by reading the temperature, it can also give you an indirect count of how many number of people in an average are inside the house. It can sense whether am I sitting inside the house or not. So these things are possible by using this thermistor. This bulbs, hue lamps from Philips, what they do is you can adjust their intensity based on your mood. If you are happy, it can be bright. If you are a bit dull, it can be a bit dull, and so on. It can also change their color according to the human mood level. Okay, that is possible by using this Philips hue lamps. And for your information, Philips have officially declared that they are no more an electronic company. They are a smart technologies company or an IoT company. And this is a garage door opener. So this can automatically open and close the garage door whenever your car arrives inside your house or inside the street. And the beauty of this Internet of Technology is we all know that the devices which have been manufactured or which have been found after the emergence of these technologies can be seamlessly integrated into IoT. But the story doesn't stop there. This IoT enable you to bring in the devices which have been found earlier to emergence of IoT also into the domain of IoT. I'll make it more clear. For say, if we have a chair, for example, let's imagine a normal chair, sitting chair. A chair can be connected to the Internet of Things by adding some devices to it. For an example, I can attach a RFID or I can attach a RFID tag to it. From the tag, I'll be easily able to track where the chair goes. Very simple example. So the IoT also welcomes the devices which were existing before its emergence into its fold. And this is a weighing scale machine. What this machine will do is, yes, we all know it will show us the weight, but it doesn't stop there. It can also send it to the dietitian. So accordingly, depending on your weight, they will start recommending the diets for you, and it could be monitored very easily. This again, IoT is not only for human beings. I personally believe that this world is for all. So this is a dog's collar whistle. So what it will do is, it's a dog's collar. Once you tie this with your pet, you will be easily able to track where it is roaming, what it is doing, and you will be able to know its GPS locations very easily. I was giving an introduction, who cares? Okay, these are all big technology, big devices, costly devices. You may be saying that I may not be using it in my lifetime. It's all fine. These are all the people who care. Okay, Cisco, GE, IBM, Samsung, and Google. How do they care? They care to the tune of millions and billions. Internet of Everything by Cisco. Cisco is a pioneer in that. If I'm right, they are also going to come up with a dedicated IoT router. When I saw an year back, it was in the beta version. So, Smarter Planet by IBM. IBM has entered into IoT arena long back in name of a Smarter Planet. Industrial Internet by GE. GE is focusing on industrial-oriented Internet of Things. And I said, we saw a thermistor manufactured by the company called Nest. This is one of the notable acquisition which took place in the IoT field. Google acquired this Nest for the tune of $3.12 billion. Samsung, as you all know, they are a mobile manufacturing company. They acquired this small company, SmartThings, for $200 million. And in Europe, they formed a consortium in name of Internet of European Things, where all the educational universities, companies, they all came together. They joined their hands, and they have been working on developing or deploying Internet of Things in different field. A range of applications starting from healthcare, automotive, education, whatnot. So they have formed a consortium, and they have also pumped in huge dollars to encourage the research directions in the Internet of Things. And again, Gartner identifies top 10 strategies, technologies. This is one among top 10. How big it is? You can see 10 million devices now at present, currently. When I say current, this data is before or around 2015. Okay, so in 2008, there was internet. Internet was almost becoming popular in 2000, and in 2008, after the emergence of smartphones, internet became an household item. So in 2015, the number of devices available in the entire globe was 10 billion devices, approximately equating with respect to human being. It comes around 1.5 per person. In the 2020, already they say there will be 50 billion devices, accounting to 8 devices per person. You can imagine now itself you can count how many electronic gadgets connected to internet are available in your home. In case if there are 4 family members, obviously there may be 3 to 4 mobile phones with internet connectivity. Apart from that, if you have a laptops, both the laptops will be connected to an internet, either through the fiber net or through Wi-Fi connections. So almost 6 to 7 items, gadgets will be available in an ordinary middle class family with internet connection. So when these devices start communicating among themselves, that's going to make a very huge impact on our day-to-day life. And these are all the estimated spending. Automotive industry, they say it will be to the tune of, see, again, when we talk about automotive, there was an important article which says that in the next 3 to 5 years, the heavy competition for BMW or Benz they will be facing the stiff competition from Google and Samsung. Probably we all know why Google or Samsung or Motorola will be the huge competitor. Already Google is into this driverless vehicle. So these guys will be the one who will be competing with this automobile giants. Healthcare, 69 billion, already now we are witnessing it, the remote telemedicine and remote assistance, remote diagnostics and so on. Utilities, consumer electronics. Consumer electronics is again a very big market. Every week you see there is a smartwatch popping up from a different vendor. This is very much big. The areas of spending, you can see as per 2015 statistics, 32% of the money or 32% of the budget was spent on Internet of Things. Okay, I understand. Tech giants, business, huge automotive industries, huge people, big white collar people. Yes, it may be necessary for them to embrace this technology? Why should I care? As a common man, why should I bother about this Internet of Technology? My dear friends, my answer is, we all love to enhance our human life, right? We always thrive hard to improve the quality of our life by getting better health, better safety, better comfort, convenience, and wisdom. Okay, probably I don't think so that you'll have any arguments with health, safety, comfort, and convenience. How come wisdom? How can we achieve a better wisdom by using this kind of technology? Let me throw one or two examples to you. See, with respect to sensing, the wisdom can be achieved by sensing information or sensing the real scenario, getting the data. From data we form the information, from information we form knowledge, from knowledge we form or we get wisdom. How this is possible? By using this simple Internet of Things. Let's take this Google flu example. You would have heard about Google flu in the early 2010s, and after that, this was a flu, was a Google flu. I mean, we cannot call this as a Google flu. It was a swine flu actually. The project name is Google flu. Okay, that's why I have termed it as Google flu. Swine flu was spreading across mostly the African countries. Thank God it didn't touch most of the Asian countries. We had little impact, but it was not to the tune of COVID-19. So swine flu was spreading across the West and African countries. So Google they started a project. They named it as a Google flu. They didn't do any great thing. What they did was they recorded the people's search pattern. Primarily, they recorded how frequently the people used to search the word flu and its related words like treatment for flu, medicine for flu, and so on. By getting this data, what they did, by collecting this data, they alerted this kind of most of the African countries, they alerted them, they predicted that the particular geographical location is the place where the more number of searches have happened. If let's imagine that in a GPS location of 180 or 160, there has been lot of queries regarding this treatment and medicine for flu, then it is an indicator that the disease would have started spreading in that particular location. They identified this and they also gave this information to the respective government, through which they were able to take some countermeasures, and they were also able to contain the spreading of disease from in the nearby places. Okay, so this is again an example. Again, I am going back to my previous slide. They sensed the information. They collected the data through sensing, that is through the Google search, and then they converted that into information. For example, like finding out which geographical location the search was happening very hugely, and they converted that into knowledge. They alerted the respective government. So once the alert has been given to the government, they will see to that sufficient drugs are maintained in the pharmacy stores available in that area, and from that they were able to encounter a pandemic. They were able to encounter a spreading of pandemic by using this simple Google flu project. And again, I need not to say, prediction of natural disaster is a very big challenge. But if you look at countries like Japan, where tsunami is a very commonest thing, like a rainfall in Kerala, tsunami in Japan is almost equal to that. So what they did was, there was a project where they used to see that they used along with Twitter. Suddenly, on one given day, on a given day, the average wake up time of people in the particular city was earlier. Average wake up time, because you all know, once we wake up, where do we go? We roll over from the bed and we immediately look into our mobile phone. We log in to our WhatsApp or to our Twitter. So they used this habit of the normal human being. On one day, there was a sudden change in the average wake up time of people. They all were looking at the Twitter at 4 a.m. So this was an indicator for the local body that something would have happened in that area. It could be bad, good, or something. So this warned them. So they immediately got the alert and they went. And when they went there, they witnessed that there was a tsunami. So these are all the kind of examples where a normal technology could also lead us to a place where we see wisdom. No, we will be able to achieve wisdom by leveraging these kind of technologies. Okay, again, I'm not getting into all this explanation. I wanted to set the tone. So I have given you the ample examples of what are the places where IoT can be used. Connected home is a prime example. You can see smart lighting. I already discussed about this Hue, and these are all furthermore smart locks, smart doorbells, and ring video doorbells, and so on. Energy sector, again, if I'm right, government of Puducherry was venturing into this, but I'm not sure any other state has come up with that. But it's a very common phenomena in the West. They will fix an energy meter in your house, and you'll be able to see how much energy are you consuming on a day-to-day basis. Infrastructure. When we talk about infrastructure, the prime example is the Barcelona smart city. I would request all the participants to go to Google and after the session, not now, Barcelona smart city. Why Barcelona smart city? It's not the first smart city. We all know New York, Washington, a lot of Ottawa, a lot of smart cities have come up in the west side. But when we look at Spain, Spain is more like a developing country. So by leveraging these technologies, the smart city, Barcelona smart city, if you see there, they were able to save around $50 billion by rearranging the parking system. They were able to save more than $20 billion to $30 billion by monitoring the street lights, switching on and switching off of street lights properly by using this Internet of Things application. This again, from the picture, you can understand irrigation, the smart irrigation in the common areas. They were able to achieve, or they were able to save billions of dollars by leveraging this, by using this technology in this particular example. So I would request you to go and look into this Barcelona smart city. There's a wonderful use case for you to start getting into IoT. Agriculture, countries like Australia and New Zealand, you would have seen in the movies and other places where they have a huge number of cows, and dairy farming is a very big business there. So you can monitor monitor the cow by using this technology, IoT. Other than that, Israel is the leading technological country which has produced appreciable results by using technology in the farming. Smart farming, carbon nanotube probes, clean grow, smart watering controller, and so on. With respect to health, I have a separate set of slides for health alone. You have lot of devices, n number of devices which have come up in the field of IoT. One recent device or one recent invention is smart mirror. Let's imagine that a person is addicted to smoking. When he goes and stands before the mirror, if he gives the data like how many years is he smoking and how many number of cigarettes he smokes on a per day, the mirror will show him how his internal body parts have got damaged. That is the beautiful invention. Probably you can also go and look into the net. And these are all some other smart medicine dispensers, or a huge boon for people who are affected by Alzheimer and other old age diseases. Supply chain, it's playing a very greater role in supply chain. I'll say you one use case in India by using IoT. See, you all know India is a country where even today blood is very scarce. Blood availability or donating a blood is not an ordinary thing. Blood scarcity is still available, but we waste around 2 lakh liters of blood every day because of fluctuations of the storage devices, temperature fluctuation in the storage device. If the temperature is not maintained in the proper level, we cannot use the blood. They have to throw it away. In such way, if there was a statistics which said that we are wasting huge blood packets because of the fluctuations in the temperature. So that could be easily solved by using these kind of IoT gadgets. And other than that, Amazon Go is a wonderful use case where Amazon has tried this. It is there in UK, and if I'm right, they have also come up with the USA, where there will be no shopkeeper, there will be no guy who will be monitoring you. You go inside, purchase your items, pay online, come out. That's all. So Amazon Go, again, I recommend you to go and look into the YouTube. These are all some dashboards for which are particularly used in logistics field. Maysek is one of the biggest supply chain company which has already started embracing this IoT. Factory automation, transportation, I need not to say, they say nowadays a car or a automobile industry, 70% it is a smart industry. It is controlled by electronics and IoT. And the mechanical part takes very lesser portion there, and it is completely dominated to the tune of 70%. Day-to-day objects, we discussed about this. Smart fridge, which could say which could also give you some suggestions for recipes. Cooker, which can also say you recipes. Transparent smart window, we may need not to worry on any devices. We can make the windows as a smarter one. We can start presenting and so on. Coming to the protocol, you can see I'm going to focus on RPL. The TCP/IP suite is the key communication protocol stack that include two significant families of protocols for device communications over the network and internet. The new protocols required to enhance the TCP/IP suite for the IoT environment by providing the communications between resource-constrained devices within the IoT. Please underline this word. It is a resource-constrained network. Why I call this as a resource-constrained network? Energy is going to be a big challenge for us in making this IoT a successful one. Most of the devices are battery powered, and if depending on their frequency of operation, they may lose out their energy easily and they may become useless. So we have to accept this challenge when we are getting into this IoT field. But there are few solutions which has been already started coming up, and some industries or some researchers have also started using that. For say, in case if I am deploying IoT project in a outside scenario or in an environmental monitoring, then we can think of leveraging alternate resources, alternate energy resources like solar, wind, or hydel power. Okay, this is being tested now, but we have to wait for the comprehensive results. This is a resource constrained network. IoT devices are usually placed in resource limited environments such as lightweight medical devices, outside smart city applications, many other scenarios where power and network connection constraints is a very huge challenge. There are numerous IoT protocols available and in progress. And in the following section, we will examine the most popular ones. And my personal experience, we were involved with Ericsson R&D for monitoring the water quality of Krishna River in a particular place called Muri village in Andhra Pradesh. When we tried to deploy the sensors and monitor the water quality level, the problem we faced was it was not on the technical side, it was not on the data communication side, or it was not on the devices. It was majorly on the energy side. We wanted to really come up with an algorithm, or we really wanted to come up with this strategy where we could optimally use the resources to its fullest efficiency. I cannot have my sensors to keep on monitoring the water 24/7. So I need to fix some interval. So what is the kind of interval which I am going to fix? In 24 hours of time, whether I want it to communicate or whether I want it to send me the data every 1 hour or every 2 hour or every 3 hour, all these things become a very crucial part, because when we entered into this project, we never thought this will be a challenging part. But later on, it turned out to be a challenging part, and we somehow monitored and we somehow gave the results. So there we have also experimented by using solar energy powered sensors and devices, but still it is in amateur level. We are waiting for the market to get matured. And again, I need not to say about protocol. If I'm right, you all know what is a basic definition of a protocol. Protocol stands for set of rules. So here in the IoT scenario also, you can see there are, again, with respect to layers, different authors may come up with different framework. This is my version of layers. Application layer, you can see CoAP and MQTT. Transport layer, still we use UDP, TCP and DTLS. Whereas if you look at the internet is the place where we normally call it also network or routing layer. In the routing layer, you have IPv6, 6LoWPAN, RPL and LoRaWAN. LoRaWAN is catching up in India. If I'm right, LoRaWAN is the protocol which is being majorly deployed in Bengaluru Smart City project. The Bengaluru Smart City project is completely The backbone of the Bangalore Smart City project is LoRaWAN. LoRa is a Spanish-based company. LoRa as a company itself is involved in this, and if I'm right, Tata Elxsi is also involved in it. This is my level of exposure. Some more companies may also be involved. Okay, I'm talking about 2018 scenario. So LoRaWAN, if you are interested in LoRaWAN, you please concentrate on LoRaWAN. We used LoRaWAN for our projects during that time, early period, before 3 years. The support was very less, and it had a problem of line of sight. Okay, I'll talk about it later, but I'm going to focus today on RPL. The specialty of this 6LoWPAN is 6LoWPAN traditionally, if I want to map it to our network layers, 6LoWPAN can be considered as a candidate for both MAC layer and network layer. Whereas RPL is very commonly used protocol for research and application. I'll come to it. Other than this, if you look at the network access, again, these are all the IEEE standards which are again used for IoT purpose. And I should also mention about ZigBee. ZigBee is the protocol which is majorly used in industrial research. If you talk about IoT, in industry, they may not be using RPL. They still rely on ZigBee, and they are exploring the usage of ZigBee with respect to IoT applications. So today our focus will be on RPL. I'll try to explain you about RPL. No specific reason. RPL is so close to me. I have been working with RPL for past 2 to 3 years. The transport protocols. If you see here, all protocols explained in this section are not only IoT specific one. Some of them are generic. For example, TCP, UDP are the core protocols for TCP/IP protocol suite. Okay, they still retain their place. However, IoT application mostly use UDP, TCP, DTLS as a transport layer protocol. So each of this each of this still have a place or still have a role to play in our IoT scenario. This is what I was explaining you. IPv6, soon we are expecting that, see, already IPv6 is there. And another important challenge with respect to IoT protocol is IP-based sensors. I'll explain you that. IP-based sensors have started coming up recently, but we require IP-based sensor to successfully execute an IoT protocol, IoT application, IoT project. 6LoWPAN, it is named as 6LoWPAN because of this IPv6. Yes, a routing protocol for low power and lossy network. So that is the expansion of RPL. R stands for routing protocol. RP stands for routing protocol. L stands for low power and lossy network. From the name itself, you can understand. It's kind of a disclaimer. They say this is the protocol which is compatible for low power and lossy network. IoT routers, like other devices in IoT environment, are resource constrained. As they perform in a low power and noisy network, there are limitations that make it almost impossible for us to use the traditional routing protocol. One of the most popular routing protocol used in this domain is RPL. We cannot imagine, we cannot use the traditional protocol. In the first hand, we should understand that the scenario what we are talking here is completely different from our traditional network scenario. That's why we go for this kind of dedicated protocols. I'll introduce important terminologies pertaining to RPL, and then I'll slowly show or explain you how RPL actually functions. It functions on the base of distance vector. You would have heard about DSDV protocols. Distance vector is an important type of, it's a passion in which the protocol works. There are a lot of protocols. You see, the classification of protocol itself is a huge topic. On demand, the stored one, and table based, and a lot of other class of protocols are also available. So this belongs to distance vector. Distance vector is the scheme where we calculate the distance and we store the distance, and the routing happens based on the distance already calculated. Routing is done by each and every node in RPL. That means all nodes in the network act as a router transmitting IPv6 packets to the next hop. based on the destination information. Don't worry, storing and non-storing. Remember this word. RPL operates on two different mode. One is storing and another one is non-storing. It uses a concept called DAG. You would have heard about this DAG in graph theory and data structure. It's again the same DAG. It is a graph that contains no cycle. You can see in the figure, it contains no cycle. We see such kind of graphs in spanning trees. Okay, we usually see these kind of graphs in spanning trees. In a directed acyclic graph, the graph cannot cycle round or return to the same node. For example, if it starts from this node, it should not traverse and come back to the same node. That is what I'm talking about. So this is not allowed. If it starts from this node, let's imagine this. These are all the nodes. If it starts from this node, it should not come and stop here. It cannot form a cycle. Routing loops and count to infinity problems where messages go around and round loops and do not reach there are addressed by RPL by using rank. This rank is nothing but the calculation of distance. I'll show you. You can see here, these are all the terminologies. Root node is the one we call as more like a parent node. It has no outgoing edges. It will accept only incoming edges. You can see in the picture, it is all incoming edges. Up, let's imagine this is the root node. Up it is any edge that is directed towards the root. For example, this is called up. Down, it is any edge which is directed away from the root. In case if there is an node, for example, let's imagine this is down. Destination oriented DAG. This is a special kind of DAG where each node wants to reach a single destination. You can see here in this picture, all these nodes are competing to reach this destination node that is a single destination. That is what we call it as a special DAG called destination oriented DAG. You may be wondering, like, why am I saying all these terminologies? My dear friends, please understand, RPL works in this way. It performs, or it consists of all these features. That is what I'm trying to explain you. Rank, you can see here, with respect to this node, rank is 2 because it is 1 and 2. So rank is nothing but the distance away from the root. So this node, let's imagine this node is D. The rank of D is 2. Let's imagine this node is C. The rank of node C is 1. Likewise, if this is B, then the rank is 1. If this is F, then the rank is 2, and so on. Okay. Objective function. You would have heard about. If you are, in case if you have awareness or if you have come across artificial intelligence or optimization techniques, then definitely you would have come across this word objective function. Here, it helps us to reduce whether we are near to the root or away from it. So optimization, objective function is the one which acts as an indicator which informs us where are we actually. Let's imagine I want to go to a particular destination. From my current place, how far am I from the destination? That value will be indicated to us by using this objective function. It is decided by the programmer or designer. Why we say this? Because you all know at the end of the day, we simulate all these scenarios. When we simulate this scenario, we will be fixing what should be the objective function. So the notion here is we should always try to minimize this. That is the optimal way. It can be, see, what could be objective function? Objective function could be an energy, it could be a latency, or it could be the routing path, and so on. Rank, this we discussed already. It is the distance from the root. I hope you all you would have understood. This is C and this is D. Rank from this distance from the root is 1, so the rank is 1. Distance from the root is 1 and 2 for C, so rank is 2, and so on. RPL instance. When we have one or more doodags, you can see here, this is one doodag, this is another doodag, one destination, right? So here there are 2 RPL instances. We call this as a instances. The number of doodag formation is called as RPL instance. Doodag ID Each DODAG has an IPv6 ID, 128-bit. You all know it is a 128-bit. This ID is given to its root only. Only the root will be allotted with the IP address. And as long as the root doesn't change the ID, root doesn't change, the ID also will not get changed. Each new shape of DODAG means a new version. That's what we saw. It is where goal is a state where a DODAG wants to reach. It can be a wired network. The goal is different from objective function. You understand that? Objective function is something which we actually try to minimize, right? We try to minimize. But goal is something where we really want to reach. For an example, let's imagine I'm going to travel from Chennai to Pondicherry. My objective function is distance. So my objective function is distance. What I will look at is I want to reduce my distance. That is my objective function. But what is my goal? My goal is reaching the Pondicherry. So in this process, this is the goal and this is the objective function. I hope I have made it clear. So grounded. When a DODAG reaches its goal, it is called as grounded. So when I reach Pondicherry, it is grounded. So when successfully we reach the goal, we say it is grounded. Floating. When a DODAG isn't connected or yet to reach the goal, it is called floating. You can see here, we have not yet reached. There is a gap. Okay. So F in this figure shows the floating DODAG. Parent. Parent is where the arrow is pointing towards, and a child is where the arrow comes from. You can see here, this is the parent, this is the parent, and this is the child. For this is the parent and this is the child, and so on. Sub-DODAG, it can have any subtree. Within the DODAG formation, you can also have a lot of subtrees. So those things we call it as a sub-DODAG. I hope you will not get confused with RPL instance. RPL instance is number of DODAGs formed in a particular network. Sub-DODAG is within the DODAG. If you have subclasses, then we call them as a sub-DODAG. Storing is the process where nodes keep the whole routing table. They know how to go from one node to another. This is more like prepared one. It has already got the routing table ready, and whenever we want to find a destination based on the routing table, it will be directing the nodes to travel or directing the packets to travel in the path. Non-storing, they are very simple. They don't store an entire routing table. They only know about their parents. Here we are not going to store the entire routing table for the entire network. Here only the parent, the path to the parent will be stored. Through that, we have to explore and we have to reach the destination. So if you look at the whole DODAG, except from the root, has to maintain a uniformity. It has to be either storing or non-storing. We cannot mingle both storing and non-storing. And these are all some pictures which will depict the storing and non-storing pattern. I have left it in the slides. You can go and look at them after the session. This is for non-storing. You can see the picture itself. Storing each and every place. This is non-storing mode. So the entire table will be available or entire root will be available in the parent node. You can see there, they go there and from there they start finding the destination. Storing mode, each and every node will have a path so they can directly go and reach the destination. These are all very important control message. When we talk about RPL, you should be aware of this control message. DODAG information object. Remember them, DIO. I have also given a small picture here, new and old. For example, this is multicasted. A given node in DODAG may multicast this message, which lets other nodes to know about things like whether the node is grounded or not, whether it is a storing or whether it is following a storing or a non-storing pattern, and so on. DIS, when no announcement is heard. See, DIO, the old node, the existing node should declare that, hi, I am available. Is there anybody who is ready to join with me? DIS is meant for new node. A newly arrived node has to ask, right? It has to ask, hey, anybody there? I need some help. So that is what DIS is meant. DODAG advertisement object, DAO. So it is a request sent by a child to parent node. Are you ready to accept me as my child, as your child? That is the DODAG. If this old node accepts them as a child, then they respond by sending back the acknowledgement message. And consistency check is completely relevant to security. I'm skipping this here because consistency check is not commonly used in the general RPL protocol. It is still under exploration. This is again a picture where let's imagine a guy is caught in the middle of a desert. Let's imagine he is a new node. Is any dodag out there? See, you can see here DIS, it's sent from the new one. Yes, let's imagine if you have watched the movie PK, the launch space vehicle will come and it will leave the Amir Khan in middle of a desert. It's similar to that. Is any dodag out there? He is calling out for a help. That is DIS. There is already a dodag which is formed in the desert, and they are supposed to see, they may be grounded, floating, or storing, not non-storing, and so on. So now they have to respond back by using DIO. Now he is asking, okay, he understood that somebody is there. He is asking whether will you accept me as your part or as a child. They are saying yes or no. Depending on the reply, they send their acknowledgement, and this is how the formation is happening. So that example I have also given you technically by giving the pictures here. I hope you can go through and read by yourself. It's again, don't worry. I have explained you through the pictures. Here I am giving you in the algorithmic format. That's all. You can see here multicast DIO in the figure. You know, DIO is the one which is being multicasted by the existing one. This is the old one. It is multicasting. So rest of the nodes receiving the DIO will trying to join. They are trying to join by sending the DIO. Once it is accepted, it is DIO acknowledgement is sent. And whenever a routing takes place, the rank will be taken into consideration. Rank is the one through which the distance is maintained. This is another example. I have given you another scenario. It also performs the same thing. DAG and DODAG. Again, these are all some more pictorial explanations. The same concept what I explained you now. You can see here how are we building a DODAG. I'm in charge. So somebody is declaring that DIO. So they will respond by DIO. Then DIS is sent and they are communicating and acknowledgement is sent. And each leaf node at the end of line will have only one route to the root. This rank you all know, this is the distance from the root node. So these are all extensions for RPL protocol. The cognitive RPL is a new version, extensive version of RPL, which is already available in the market. You can explore. If somebody is planning to do your research with respect to IoT, particularly with respect to protocol, this is one such area where you can look upon. Channel aware routing protocol. It's a distributed routing protocol. It is majorly contributed towards underwater communication. People who are using underwater sensors, guys, this is the protocol for you. Comparison of type of RPL, you can see there. This supports. This is the naming convention. Server technology, all of them. These two support server, whereas this, as you know, it is underwater one, so it doesn't support. So security. That's why I said it is still under development. We cannot say that security has completely perceived in this RPL protocols. Storage management, it is supported here. Here it is not supported, and it is supported. Data management, supported, and supported. These are all network access protocols. I'm not going to get into it. These are all available. With respect to bandwidth, if I want to classify the protocols with respect to bandwidth, these are all the bandwidth. The lower bandwidth, you can see RFID, NFC, Bluetooth, Zigbee, as I mentioned, and LPWAN is also one which occupies in the lower bandwidth. Medium bandwidth are the one which comprises the normal networking protocol. You can see here up to 5G, 802.AC, AH, all those things will be compatible. And these are all the way in which we can map. So the PAN, LAN, and WAN, these are all the way in which you can map. So 6LoWPAN can cover PAN applications. Wi-Fi, again, is the medium which you have to deploy for covering the LAN, the range of LAN. For WAN, you have to again go for LoRa, Sigfox, weightless, and so on. Okay, LoRa is very commonly used for this WAN coverage. So my experimentations, how I have taken up this RPL protocol, how I have done any study or experimentation. I'm aware of the time. It's 7:08. I'll try to close within next 10 minutes. So Contiki OS and Kuja Simulator, you can see here, Contiki OS is just like another operating system, but it is an open source which is majorly meant for IoT. You can try experimenting low power microcontroller or low cost by using Contiki OS. The communication components which are internally supported by this Contiki are 6LoWPAN, UIP, and RPL also. These are all some protocol stacks. You can see here. I have separately shared a Word file where it will say the guidelines for you to install Contiki OS and Kuja Simulator. That I have shared as a Word file to the organizers, to Morgan sir and PVS sir. Probably they may share it with you. Otherwise, you can ping to me. I can also share it with you. So assuming that we have Kuja installed in our system, the Kuja installation requires Contiki OS. Contiki OS operates on a VMware. It's basically uses Ubuntu operating system. So if you are using Ubuntu, you can directly run this. So we have to go to the terminal and type. You can see here, wait for the blue screen of Kuja to appear. Now we are going to select the new simulation, and you are going to give a name for that new simulation. I'm just giving a simple RPL. And you can see here, it will say what is the radio medium, what is the mode, what is the random speed, all those things you can set. But initially, if you are doing it for the first time, leave the default values. You can have mode. Mode is, that is the specialty of this Kuja simulator. When we try to simulate here, in the traditional NS2 or NS3, we will not be able to exhibit the characteristics of a sensor node. Even here, we will not be completely able to exhibit the characteristics of the sensor. To a certain extent, we will be able to use the modes. Here, we will not be using node. Please understand, it is mode. Okay. So here we will be selecting the mode. Usually used mode is Sky mode. Sky mode is the one which I recommend you to use if you are a beginner. Then we give a description, UHub. Then we select. We are selecting simple UDP RPL. See, RPL, this file will be default stored in your folder where you can go and check. It will support both UDP and TCP. You can take anything. So I am taking UDP. Then we are setting up the receiver. So we are setting it up. Now we are adding how many number of modes do we require. Okay, so if we are a receiver or a sender, we need to select both sender and receiver. You can have n number of nodes. To start with, I am having one. I can also mention the positioning of the node. Where should it be placed? Not node, mode. And you can also add number of modes depending on your requirement. You can see here, once you do that, it will appear here. This is one. This is the mode what we have created. And then I'm going to add a switch. Earlier I added a hub. Now I'm adding a switch. Now here I'm adding. Earlier I added a receiver. Now I'm adding a sender. I'm adding 3 senders, and I'm also selecting the mode type. And once it's done, you can see here, these are all the 3 modes which are available in the network. And you will see this kind of picture. And once you start running them, it will give you all the details for the simulation. You will also be able to see the packet transfer here. And the beautiful part of this Kuja simulator is it will also give you the entire analysis of all parameters like throughput, routing overhead, what is the latency, all such things. Okay. So we can also move them from out of radio range. The green is the one which indicates the range. And we can also look, see, once you go to the view folder, view option here, you can also look the IP address. You can also see them with the IP address, default IP address allocated. And as well as in the zoom itself, in the view itself, you can also see the radio traffic and what should be the mode type. All those things will be visible there in the view. So finally, once you run, you will have data available here. You can go to tools and you can select what are the graphs which have been generated for the respective experiment, respective simulation what we carried out. So this is how the RPL protocol is being tested in a Kuja environment. I have also shared a separate document again. I have shared it with the organizers. You can also get, and you can also download and install the Contiki OS and Kuja. You can start doing this. What we did as a part of my research work, we have a team of people, my students, my scholars, me, and my colleagues. We work as a team. So what we did was we tried to change. We were trying to add some trust value into the RPL protocol. For that, we tried to change the internal coding of RPL protocol. We added some script by using Python, and even later we also added a script by using Java. To some extent, we were able to get some results, but again, it's not so user friendly as of now. See, user friendly in sense you cannot go to that level of changing the pattern in which it works. And please understand, Koja was actually contributed from a university from Australia. The prime intention of this Koja is to integrate the physical sky modes with the simulator. That is the prime intention. They have the testing laboratory available in their respective university, so they are able to do some experiments. But as a individual researcher, we can stick on with this simulator, and we will be able to experiment with this kind of RPL protocol. So this is the definition regarding protocol. If you spare 5 minutes with me, I'll show you the different hardware, software which are available in the IoT landscape. I'll not be giving any explanation. I'll be just going through the slides. You can see here what are the hardware available, sensors, the type of analog and digital sensor. These are all some common example: infrared, pressure, ultrasonic, tilt, camera. These are all the gateways. I already said, these are all the protocols. Again, we all know these are all the protocols, and these are all the gateways which are dedicatedly used for IoT. And if I'm right, Mesh Central, you can also explore Mesh Central. It's not a gateway, but Mesh Central will give you an option where you can use it as a server for initiating your communication with respect to IoT devices. It's an open source one. You can also integrate that with Azure. Connectivity, when we talk about connectivity, no other go, we have to rely on our traditional Wi-Fi, Bluetooth, Zigbee, and Thread. Thread is also a new way of communication, which is recently coming up in the IoT world. And apart from this, you can also rely on LoRa. LoRaWAN can also be used for connectivity. Open source hardware, that's where the open source hardware where the backbone upon which this entire IoT is built. You can see here, again, Arduino. Sketch is the program which is supported by Arduino. Arduino comes with the Ethernet, Wi-Fi, and so on. Raspberry Pi, again, Raspberry Pi is a mini computer. You can consider it as a kind of a mini CPU. You can run that. I mentioned about Mesh Central. Mesh Central can be installed or can be run by using this Raspberry Pi. You can use this. So I have also given you the difference between Raspberry Pi and Arduino. These two are very commonly used boards. So I have given some explanations. And these are all some other boards which are also available in the market. Apart from Arduino and Raspberry Pi, if you want to rely on some cheaper boards, then you can also go for Arduino Uno, or nowadays, usually people go for ESP boards. It comes around 1200 or somewhere around from 900 to 1200. So you can rely on ESP boards. And if I'm right, NVIDIA has come up with the controllers embedded with GPU capability, which is also currently being used for IoT experimentations, but they will cost you around 10,000 to 11,000. So these are all some more devices. You can see Intel Galileo, Intel Edison. It is almost like a phone. It has a capability of a normal phone. And Parallella, BeagleBone, and so on. Okay. Coming to the prototyping, there is a software called Arduino. You all know Sketch is the language which is based on the C library which is used here. Wiliodrin is another prototyping software where it will be more like if people who have been exposed to VB, it will give you the feel of VB where you can pull in the box. For example, if I want a sensor here, I can pull it from here and I can expect this box to act like a pressure sensor. So this is possible by using this Wiliodrin. And Eclipse and Vim also supports. Eclipse can be used for writing your Java programs or simulator programs. VM Embed Online is the place where you can store your data online. Intel XDK machines. Xively is again a dashboard. You can consider this more of a dashboard where you can see different type of services which are happening in the IoT. And Microsoft Azure also supports. You can think, you can use Azure more in the perspective of storage and also as a service. And NetSim is again a simulator. It's not an open source simulator. I mean, you have to pay a charge. I mean, if I'm right, a Bangalore-based company is the one which is marketing this NetSim. So it is also a good software. I have used one, or I have tried MQTT exploration by using this NetSim. And Cup Carbon is also a simulator which is based on Java again. Based on Java. This is the one which is used majorly for smart city applications. Okay. SimpleSoft is another simulator which you can think of using. So you can simulate CoAP, MQTT, HTTP using this SimpleSoft. And ANSYS ANSYS is nothing to do with IoT, but what they do is they give a different designs for IoT devices, which could also enable us to create a simulation-based driven environment. And Contiki, that's what we saw. Octave is almost similar to your MATLAB. So the MATLAB users, you can also think of using Octave. Octave will give you a seamless integration with respect to Vilodrin, and you can also use this Octave as an IoT server. IoT server, free server is also available, but you have to register and you have to use for the free trial period. And AWS IoT tutorial, it is link it one where you can link your IoT board directly to the AWS IoT service, where you can store data. Repository can be AWS cloud. Watson of Thing from IBM under Watson, they have dedicated service called Watson of Things. And Google is in the verge of coming up with the OS dedicatedly for Internet of Things applications. They have named it as Brillo. Brillo is Android-based embedded operating system. Probably they came up with the beta version in 2015, and I hope soon it will be hitting the market. Particularly for MCU platforms. These are all further softwares. I leave you for your exploration. Cloud plays very important role in IoT. As I said in the beginning, it's all integration of technologies. So you cannot imagine a technology without integrating it with other technologies. And cloud computing again plays a pivotal role in IoT. Fog and edge is an upcoming scenario. If I want to explain it in a very simpler sense, it's more like a local storage. See, there may be some resistance from the users when we say that we are going to store their data in a cloud. To avoid that, you can also have an intermediate local storage where the sensitive informations can be stored and processed in the local storage itself. That is what we call as a fog or edge. Edge is the name used by Intel, and fog is the name which was introduced by Cisco. Okay, so that is the story behind that. It is also picking up. So there are a lot of research which is going in this area, fog architecture and IoT learning path. There were some questions like, what are the different areas where a person can explore with respect to IoT? Technology applications, sensors, hardware, architecture, software, communication and networking, data management. And I forgot to say one more important area is, standards, IoT standards and frameworks. It's a very, very important area. We don't have any standards and frameworks. To what extent we can accept error rate in a sensor? We don't have any standards so far. So IoT landscape, these are all the different companies who are playing a different role in different verticals. Gaming, starting from gaming, pets, toys, healthcare, retail, you can go into it. You can look into it. These are all some notable startups in India after 2010. Personally, I have seen Hug Innovations. Hug Innovations have come up with a lot of IoT tools, SmartRun, CarSense. So these are all some companies which have gained momentum in the last decade. Challenges, energy efficiency, that's what I said. It's a resource constrained network. Connectivity, again, we depend on a third party for a connectivity. Integration and simplicity. See, I may claim that I'm an IoT user, but still I have to integrate a lot of things. I may claim that my smartphone is a wonderful example of IoT. Okay, but I need to have app installed in it. I need to have a proper data, and the data should go to the respective location. From there, I should be alerted, and so on. So even though we call ourselves as IoT users, it requires a lot of integration. We have to rely on a lot of 2 or 3 devices for implementing or executing a successful IoT project. The evergreen challenges in any upcoming area is security and privacy. See, the Nest thermistor, I said earlier that it can even detect how many people are staying inside the house. That's fine, as long as they don't reveal who are staying inside the house. For say, you take my data are going into healthcare application, or if my heartbeat data is going into a healthcare repository, it's fine. But it should not send any of my physiological parameter without my consent. So these are all some privacy areas which we need to look upon. So it's going to be evergreen challenge for us. Summary. So I have given you the introduction, hardware and software, protocol, particularly RPL. I have explored other protocols. I have given you only the other protocols, but I focused only on RPL. How a DODAG is created, what kind of passion in which it works, and so on. Landscape and startups and challenges. To conclude, the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. So this is a statement from Mark Weiser. This was one of his statements which he published in Scientific American in 1991. So I believe personally, any technology to be successful, it has to get immersed in our life. We should not think it as a technology. It should not be something above our head. It should immerse into our day-to-day life, and that's the point where the success actually starts. So these are all references. Any questions?
Thank you, Dr. Bhalaji, for your
Thank you,
wonderful presentation.
Thank you, sir.
People are asking to stick on your video.
Yeah, 1 minute, sir.
They would like to see you.
Okay, no problem.
Okay.
Yeah, I'll do that.
Camera switch on.
Yeah. I'm switching it on.
Okay. Because there have been repeated requests.
Okay.
Because the flow. The flow was so good, so I didn't want to disturb.
No problem, sir. So I thought they will be interested in looking at my slides, but fine.
So, indeed, it is an excellent presentation, and you have given a total overview of the subject, and also you have touched upon the protocols. So there are a few questions.
Yes.
Maybe you can take it up briefly.
Yes, sir.
See do you suggest any specific guidelines to choose a protocol?
Okay. I think when I suggest you to take up a protocol, it all depends on what layer you really want to work. For example, if your background is from electronics and if you want to dwell into Mac layer, then I would suggest you to take up 6LoWPAN and you can start working on it. No, if your background is from IT or computer science, you want to work on the application side, then I would recommend you to consider CoAP and MQTT protocol. So it all depends on from which area you actually come from. If you are from an electrical background, you want to work, then I would recommend you to go to IEEE 802 versions. You can take up a protocol there. From there, you can start working on it and come up with some kind of solutions. That's how I would recommend you the protocols.
Okay. Do you have any recommendations for what type of databases are used in IoT applications?
Okay, sir. Firebase is the database which is commonly used in IoT applications. There are a lot of slew of apps available which can seamlessly collect your data. And usually, if you see, Firebase is a database which is again introduced by Google. You can always rely on Firebase. It's a lightweight database system which is more compatible towards your IoT protocol, IoT applications. But again, if it is it's again a context dependent. If you are using IoT for a critical application, then I would recommend you to go for a traditional databases. you cannot play with the healthcare kind of applications. When you are into a healthcare application, I recommend you to go for a standard databases so that the operational prediction operations will be more robust and more standard.
Okay. Can you briefly explain about the skills required for an IoT professional?
Okay, so skills required. First skill is you should have a passion. You should have a real passion, uninterrupted passion towards observing new things. Second skill, I don't think so. See, here again, you can choose. If you are interested in programming, there is a you can also manage it with the programming system. I mean, programming languages, whatever I mentioned. Apart from the simulation software, MicroPython. I would recommend you to look into MicroPython. MicroPython is the new language which is particularly designed for enhancing this IoT applications. So if you are a programmer, get into MicroPython and start learning it. Otherwise, you don't require any specific programming. You can always get into this kind of simulation software. If you are happy with getting the results from simulation software, I don't think so you have to learn any programming. But if you are interested in creating your household IoT items, then you should think about getting into programming. So my recommendation at the current scenario will be MicroPython.
Okay. Could you please briefly explain IoT cybersecurity threats and protection features?
Okay. I would recommend you to go and look into a kind of explorer called Shadon, SHADON. It's a search engine specifically meant for detecting IoT threats. IoT threat is still a vulnerable one. So, I mean, in one sitting, I cannot give a proposed solution for IoT security. Rather, I would suggest you to take it up as a research area and you can start working on it. The existing mechanisms, yes, there are a lot of threats on IoT scenario. The quite possible solutions could be real-time encryption algorithms, the dynamic encryption algorithms, or we talk about real-time encryption. Real-time encryption is a very hard topic with respect to IoT security that you can always look upon, and the standard hashing algorithms can be seen as a candidate. And very recently, in case if you are a tech savvy, you would have heard about zero trust. Zero trust is also a very new upcoming area in cybersecurity, which can give us some solutions to make IoT as a more secure one. But still, it's under a research.
Okay. Can you give some examples how IoT has been used in COVID testing?
COVID testing, probably you can use IoT as an important technology to monitor whether the social distancing is maintained or not. If I'm right, there is a company called Entu Technology. They are basically a very normal company, Chennai based or Tamil Nadu based company. What they have done is they have implemented this IoT technology. When I say IoT, please don't mistake that only sensors, RFID only comes into picture. No, your CCTV cameras can be an input source for your IoT. What they have done is they have installed the CCTV camera in the collector office, Tirupur collector office, to maintain or to verify whether people are maintaining the social distance or not. So by using this, capturing the images, it will be directly sent for the processing. If they find people are not maintaining the social distance, immediately the alert is given to the respective people who are in place. That is one such example. Very simple innovation. We are also proposing to our institution, like we start using ultrasonic sensor. Imagine ultrasonic sensor fitted to our shirt button or to our dress or to our ID card. We can ensure that people are not moving so closer to each other. It can give them alert.
Okay. See, what type of investment would be required for an IoT implementation?
Okay. So this is again a subjective question, sir. It all depends on what kind of product are you looking for. Are you looking for a product customized to again, I would say this is more of a startup and ecosystem based question, where I would recommend you to first of all have a thorough market study, like what are the areas where you really want to venture into. So once you are satisfied with your idea is going to be a captive idea, then you can venture into it. But budget, I cannot say without knowing the project or without knowing the subject. But I can say to this extent that you need front-end devices which will be used for monitoring or capturing the data. You need middle layer devices, which will ensure that the data communication happens successfully. And you need some backup devices. Some backup devices can be used for processing the data. And again, you need a front-end app or some software which could deliver you the observed data in a useful manner. So this is the ecosystem. May it be any company, may it be any product, you have to follow this ecosystem.
No, but what about the legacy system which cannot be compatible actuators?
Actuators are not meant for normal domestic applications, sir. Actuators, I would advocate them for industrial Internet of Things. Industrial Internet of Things, let's imagine a mechanical industry. If a mechanical industry, let's assume that there is a machine which precisely supposed to have a particular value of dying parameter, then I can use an actuator to see to that it doesn't overdo or underdo that particular operation. So in that way, actuators may be useful, and even actuators can come into picture when we are talking about control. When I want to control certain systems, let's take irrigation system, smart irrigation system. If I want to control certain devices, then I may rely on an actuator. Actuator is also an important tool which can be used in the IoT family.
Okay, how do you define the return on investment on personal IoT devices?
I'm not a person to answer this question because I'm not into any business. So I skip this question because I don't have any answer as such.
No, because sometimes it becomes extremely difficult to invest so much. So that's the reason this cost benefit analysis is one of the main thing.
Very, I completely accept, sir. But I think a lot of fortunately, I have been always working with industries, and our finance support was taken care by our institution. So we purchased LoRaWAN. We did projects with Ericsson. Those cases, we fortunately, I was not much bothered about the financial constraint. So I'm not in a place to answer this question.
These sensors, what type of internal backups, like sensors failure, how will you take care?
Sir, that is a very big question, actually. See, but let me be very frank with you. Sensors, you can purchase sensors. If you go to Ritchie Street, you can purchase sensors from the tune of 50 rupees to 5,000 rupees. But there are no standardization so far in India with respect to these kind of sensors. There are a lot of efforts. Even I'm working along with TNEGA, Tamil Nadu E-Governance Agency, where recently we came up with the framework for blockchain. Similarly, I'm pushing them to come up with the standard for these kind of IoT applications also. At least if government comes up with some kind of document, then that could be considered as a standard one. But your question is, this question is valid. Malfunctioning of sensor, see, if it is binary, like if sensor doesn't work, it's not a problem. But if it malfunctions, it's going to create a huge problem. Imagine a healthcare application where sensor is giving us a wrong data. That could cost us a human life. So that is the area which need more maturity, sir. So, but if I'm right, some of our Indian IITs have started manufacturing their own sensors. So we are also coming up with the Indianized sensors. So thanks to Make in India campaign, a lot of IITs have come up with biosensors and other sensors. So a lot of research and a lot of work is going on in that side.
Okay, what is the impact on IoT by 5G?
5G will revolutionize the way in which we look at the IoT. Not only IoT, it will revolutionize the way in which we use the internet. So 5G is also poised to make a lot of changes in IoT. See, first thing, data, the speed in which we communicate the data will be huge. That's the obvious thing.
Also, the latency is going to be reduced.
Latency will get improved. And again, I see a lot of opportunities also. As an academician, when we step into 5G, hopefully the protocols what we see today need to be reshaped. It need to be reformed accordingly, sir. The protocol should match to the speed of 5G. So 5G will give us a lot of opportunities to get into this exploration.
Okay, you briefly mentioned about IPv4 and IPv6.
Yes, sir.
Because that migration has to take place because then so many devices are going to be in the ecosystem, right?
Yes.
But how far we have achieved this migration?
We are gradually getting into IPv6. So if you look at IPv6, movement, we are slowly getting into IPv6, and I'm waiting for IP-based sensors. The problem is, I'll say you a typical scenario. If we don't have an IP-based sensor, whether it is IPv4 or IPv6, it becomes hard for us to identify from which sensor the data has actually originated. If I want to water a particular area of my agricultural field, I need to know which area has not got sufficient water. So right now in the present scenario, I have to do it physically. I don't have any way in which I'll be able to physically understand. I have to physically go there and identify. Wherein, if we get an IP-based sensor, it becomes too easier for us to manage such kind of very large areas. So IPv6 migration is happening smoothly. I believe within next 3-4 years, we will be completely moving to IPv6.
Okay. And there are a few questions about the impact of IoT on basically the e-commerce and connected vehicles,
Okay.
and precision farming and so on. And also there are some requests about the resources for more further information. So
Okay.
what we suggest is, if you can give us a small write-up.
Okay.
Okay. See, we will be sending the video recording to all the participants.
Fine, sir.
Right? So if you can give us some write-up giving this information and also some reference sources,
Fine.
we'd like to include it during our communication. So that way, it can be much more useful rather than just answering for a few minutes now. Okay, so this is what we feel that will give a long-lasting reference value, right?
I'll do that, sir.
Okay, so thank you very much, Mr. Dr. Bhalaji, for the excellent overview presentation. So now I request our IEEE Chairman Shaktibel to propose a formal vote of thanks.
Good evening to all of you. On behalf of the ACM Chennai Professional Chapter, IEEE Computer Science Madras Chapter, Computer Society India Chennai Chapter, would like to thank today's resource person, Dr. Bhalaji, who has given excellent lecture on IoT protocols. So on behalf of all the 3 participating institutions, we would like to extend our heartfelt thanks to you, sir. Thank you. And we would like to thank all the participants who have attended the webinar. So our thanks to all the participants. And I'd like to thank Mr. Mohan, Chairman, ACA Chennai Chapter, Mr. P. Subramanian, Chairman, ACA Chennai Chapter, for the excellent arrangement. And I would like to thank Dr. Akira for their support in organizing this event. Thank you. Thank you very much.
Thank you, sir. Thank you so much, sir. At the outset,
please go on.
At the outset, I like to thank Mohan sir, PVS sir, and all the organizers for giving me this wonderful opportunity to interact with learners from my community, from industry and other places. And I look forward to share my information, whatever information I have collected. As Sir Mohan sir pointed out, I'll be giving you a descriptive comments on your questions as well as the other resources from where I started learning IoT. Thank you so much for this wonderful session, sir.
Yeah, thank you, Dr. Bhalaji. Before we formally close this session, I have few announcements about our future program. On 10th, we are having a program on science and technology research in India. Basically, it is the topic is highlighting what is ailing in our research endeavor in the country. And Dr. T. Ramaswamy, a former Secretary of Department of Science and Technology, is going to be the guest of honor. And he will be briefing about the research directions, what India has to take in the future. And the speaker on the day is going to be Mr. Varun Agarwal, who has written a book on science and technology research what next in India. He has analyzed what are the problems we are facing, institutional issues and personal issues and funding problems and so on. And he's also come out with some suggestions. So this presentation will take care of all these issues. On 12th, we have a presentation by TCS. It is going to be on qualifier test, basically national qualifier test. What TCS has come out, they have been doing it for their internal purpose for selecting candidates. They run the test on an all India basis, mainly for the freshers. They try to assess them based on certain parameters, what they consider very important for employment. Now they are trying to standardize this test on a global basis and make the test assessment in the form of a score available. So this test assessment score is valid for 2 years. So which means that companies who want to recruit people, they don't have to go through the process of conducting tests by themselves. It is a duplication of effort and all these things are being avoided. And this test being done on an all India basis and covering all the aspects related to employment, we expect that this is going to be something like GMAT or a GRE test, where many of the universities, they depend or they get test. So where the assessment is done on a parameter-based evaluation, this may be very useful for the freshers so that, they can be potentially employed. Right now, this test is restricted to freshers, but over a period of time, this may be included even for the working professionals. So this is going to be presented by Mr. Vengusamy Ramasamy, who happens to be the architect of this entire program. So it will be something like hearing from the horse's mouth. So definitely those who are interested, please make it convenient to attend. Then we have a webinar on 13th, the role of audio video equipment in online education. Now online education has become the normal, new norm. So these audio video equipment, they have a major role to play. And this is being done by the audio video visual equipment organization, AVIXA. So this again going to be an industry body which is going to present the entire webinar. On 14th, we have a sort of webinar giving an introduction to design patterns. Basically, the design patterns are very useful in terms of standardizing application development, and it is beyond algorithms. And particularly for object-oriented systems, the design patterns play a major role. So this, unfortunately, this design pattern is not covered very extensively in our curriculum. So we are able to get an expert speaker from US, and this will be basically this will sort of keeping it at an introductory level. And based on the interest, we can even have advanced programming and how the Java implementations are done in the design patterns and things like that. So these are the immediate programs in the coming week, and we have sent invitations to our members and other groups. Please register and then attending this program. Thank you very much. And with this, we will close for the day. And our sincere thanks to Dr. Bhalaji once again, and also to the participants. In fact, they have given an excellent feedback. Dr. Bhalaji should be very happy that. And also, we are able to see the participants are almost glued till the Q&A. So, which means that you are able to sustain magnetic.
Thank you. Thank you for the opportunity.
Thank you. And thank you very much, Dr. Bhalaji.
Thank you, sir. Bye. Bye.